So I've given you today's work and the practice test. That way you can get a head start of working on that over the weekend. Today we're just going to do this piecewise function, the graphing more piecewise functions. So we've studied piecewise functions, which are functions that occur in multiple sections. And now we've studied step functions. And we're going to combine step functions and piecewise functions. Okay? So let's read this story. When I was young, my parents bought me a small plastic swimming pool. When I first set up the pool, I filled it up with a hose at the rate of 3 gallons every minute, and it took 8 minutes to fill up completely. As soon as the pool was full, I began using the water in the pool to water the flowers around the yard. I dipped a 1-gallon jug into the pool each minute, beginning at minute 8, and watered plants for 4 minutes. After that, the pool sprung a leak that drained 2 gallons every minute, which I didn't notice for 5 more minutes. And at that 5 more minute mark, I didn't write it in the story, but I let's just assume that I plugged the leak, stopped the leak somehow. You know, stuck your finger in it, or I don't know, your little brother, whatever you could to plug the hole. So we're going to graph this and then fill out a table as we go. So the pool starts out with how much water? None. So it would be the point 0, 0. So over here on the table, 0, 0. And then how much water will be in the pool 1 minute after the story begins? 3 gallons. So 3 gallons here, 1, 3. Now, is it filling up in small increments, or is it filling up slowly every instant? It's filling up slowly. So this would not be a step function, it would just be a straight line. So I would actually connect those two dots with a straight line. At 2 minutes, how much water will there be? So it's going to be 2, 6, 3, 9, 4, 12, 5, 15, 6, 18, I'm going to go 7, 21. So 2, 6, 3, 9, 4, 12, 5, 15, 6, 18, 7, 21. After 7 minutes, is the pool still filling up? Yes, for another minute. At 8 minutes, what happens? It stops filling up and the story switches. It starts to go down at 8. So if we follow this line up, we're going to have an open circle up here at 24. And we're going to connect all of those dots. But at exactly 8 minutes, what happens? Okay. That first 1-gallon scoop comes out. So at 8, it's actually down here at 23. What happens every minute after that first scoop? It goes down by 1. Is it going to go down 1 at a time, or is it going to go down continuously? 1 at a time. So this is going to go over and then drop straight down, and then drop straight down, and then drop straight down. Does that make sense? Okay. And then once we hit 12 minutes, what happens? The pool springs a leak and it starts losing water. How much water? 2 gallons a minute for how long? 5 more minutes. Oh, I didn't finish out my chart. So 8, 23, 9, 22, 10, 21, and 11, 20. And then it's going to start going down to over 1 for 5 more minutes. So we can connect those. 12. Oh, did I mess that up? 23, 22, 21, 20. What did I do wrong? 23, 22, 21. Somewhere I didn't add it up right. Oh, it's 12. It's still 1220. Okay, that's the problem. So 13, 18, 14, 16, 15, 14, 16, 12, 17, 10. So once I plug the leak, what's going to happen to that graph? It's going to level out. How much is in the pool at 18 minutes? Still 10 gallons. What about 19 minutes? It would still be 10 gallons. So this line is going to go over like that. So 18, 10. So we have three piecewise functions. The first is linear. The second is a step. The third is linear. And the fourth is a horizontal line. Okay? So for my function f of x, I'm going to have four pieces. What is the equation of the first piece? 3x. And it's actually 3x plus 0. So this first piece is 3x. What is the domain of that first piece? How long does that function actually exist? Well, we're looking at the x-axis from 0 to 8. So I'm going to write 0 less than x less than 8. Is 0 part of that first function? Yes. Is 8 part of that first function? Does that function end with a closed circle? No. It goes up and it ends with an open circle, so this remains without a line underneath it. Okay? Now for the step function, we're going to have to put brackets, that double bracket around the function, but first we need to know what the equation is. So the best way to do that is to go to that piece, which is right here, plug in two of those numbers into my stat. So turn on your calculators, stat, edit, and I've chosen 8, 23, and 9, 22. You just need to pick any two of those values. So I'll give you a second to do that. Once I have them plugged in, what should I do? Go into Stat, Calc. What type of equation is this? Is it linear? Is it exponential? Is it quadratic? It's linear because it's going down 1 every minute. So we're going to do linear regression. And I get negative 1x plus 31. So the function is negative x plus 31. Now, I have to put my greatest integer function brackets around this, but I need to ask, do the x's count by 1s, or do the y's count by 1s? And if you look, in this case, it's actually both. So if the x's count by 1s, you put your brackets on the inside. If your y's count by 1s, you put your brackets on the outside. But since this one counts by 1 in both directions, it doesn't matter where you put the greatest integer. And that only happens whenever you're gaining 1 every minute or losing 1 every minute. So I could put the brackets inside or outside. It's not going to make a difference. So I'll put the double brackets outside. When does this function exist? From 8 until 12. So 8 less than x less than 12. Is 8 part of the step function? Yes. Is 8 part of the second linear function? The leaking function? No, it's not. So we leave that without an equal to. Okay. Now we need to find the equation for this piece. So I look at two of those numbers. Go back into Stat. Edit. So I'm going to pick 12 and 13. And the y values are 20 and 18. And then I'm going to go back and do the linear regression. Anybody need help figuring that out? So the function for that piece is negative 2x plus 44. When does that function exist? What's the domain? It starts at 12 and it ends at 17. So 12 less than x less than 17. Is 12 part of the leaking function? Yes. Does 12 exist at 17? And this one's a little bit tricky. Don't those two graphs share the same point? They do. So which one do I give the equal to? And the answer is, it doesn't matter. If one graph ends in exactly the same place that the other graph starts, one of those two graphs has to have an equal to at that number. Not both. If you put both, that would be wrong. And if you put not equal to on both of them, that would also be wrong. But if they share an end and a beginning, it doesn't matter where the equal to goes. So, I'll show you in a second. What is the equation for this piece? Well, if I were to continue the chart, 19, 10, 20, 10, 21, 10, what's the equation for a line that has nothing but 10s on it? It's just y equals 10. So the function is the number 10. No matter what x value you pick, the y value will always be 10. And then when does that function exist? From 17 up to infinity. So we would say x is greater than 17. But now we have to pick. Does the equal to go on the leaking function, or does it go on the constant 10 function? And the answer is it doesn't matter. Because they share that end and beginning point, I can put the equal to there if I want, or I could put it on the other one. But that only works if they share that one point. We couldn't do it before because these don't share any points. We also couldn't do it right here because if I kept watering flowers, then this graph would actually end 1 unit lower. So we had to give the equal to the second one and not the first one. Okay. So now there are a couple questions we need to answer. How much water was in the pool when I realized there was a leak? 10 gallons. How much water does the pool hold? 24 gallons. If I don't fix the leak, when will the pool be empty? How'd you get 22? Did you just count it out? That would work. You could just count it out and figure out when that equation is 0, or the equation is negative 2x plus 44. I want to know when this equation equals what number? 0. So I'd subtract 44. Then what? Divide by negative 2, and you get x equals 22 minutes. And the last one, was it a good idea to buy such a cheap pool? Oh, okay. Whatever. Answer that however you would like. Okay, turn the page. We're going to practice graphing some more piecewise functions. Okay, so this function has 4 pieces, 2, 4, negative 3, and negative 5. Each one of those pieces is just a straight horizontal line. Okay, so the first one says the graph is at 2 from negative 4 to negative 1. So from negative 4 to negative 1, the graph is up here at 2. Is the left side open or is the left side closed? Well, we look at the domain, and that says open. So we have an open circle. Is the right side open or is it closed? Closed. Okay. The next function is at 4 from -1 to 2. So we go up to 4 from -1 on the x up to 2. Is the left side open or closed? Open. Is the right side open or closed? Closed. Okay. Now you can actually do this on your calculator. Let me show you. So I'm going to change my window from -5 to 5 on my x and from -5 to 5 on my y. So change your window to look like this. Okay. So I go into y equals. Now you can type this in, but there are a couple tricks. You have to put the equation in parentheses, like this. Okay? And then, if there are two inequalities, you have to put them in separately. So it would be -4 less than x, and x less than or equal to -1. If you type this in, then your graph won't look correct. Well, it won't restrict the domain like it's supposed to. So the first equation is parenthesis 2, and then I'm going to do x. To find the inequality signs, you go right here to test, which is second math. Second math, and then I pick number 5. Oops, I did it wrong. -4, second math, x, close the parenthesis, and then x less than or equal to -1. And if I push graph, it will draw the graph for me. The only thing it doesn't do is give you the open circles and the closed circles. You have to figure those out on your own. So over here on number 2, make this a little bit lighter. Over here, absolute value is ABS of x, and this is INT of x. But you need to remember you have to put parentheses around the whole thing. So I would do, clear this out, I would do parenthesis math, go over to number, ABS of x, and then go outside and put a parenthesis, and then I would write x is less than 2. Then down here I would do parenthesis INT of x, parenthesis, parenthesis, and then put this in parentheses, and it will show you what the graph looks like. Okay, any questions on that? All right, get to work.